Hey, I've had a few questions about the associative property, distributive property, commutative property. So I'm going to do a quick explanation of those. And let's see, here's my whiteboard. Okay, so the commutative property it applies to addition and multiplication. This property does not apply to subtraction or to division, and in a bit I'll try to explain why. This basically says that the order of your add-ins or factors does not change your sum or product. So there's a little bit of terminology in this definition. First of all, add-ins. Add-ins are numbers that you are adding together. Okay, so if I had 5 plus 7, 5 and 7 would be considered add-ins. Factors are numbers that you're multiplying together. So if I had 3 times 4, 3 and 4 would be considered your factors. All right, sum is the answer to an addition problem, and product is the answer to a multiplication problem, okay? So we're basically saying it doesn't matter the order that you add or multiply, the result is going to be the same. So the order you add or multiply doesn't matter. So if I had A plus B, that would have to equal B plus A, all right? And with multiplication, if I had A times B, that would have to equal B times A. So for example, if I had 7 plus 3, we know that that is 10. Well, what if I had 3 plus 7? Well, if I have $7 and you have $3, we get $10 together. Similarly, what if I had only $3 and you had $7? Doesn't matter, we would still get 10. And the same thing would work with multiplication. If I had 5 times 3, that equals 15. If I had 3 times 5, again, same thing, I get a product of 15. So again, the commutative property of addition and multiplication, it just means the order you add or multiply does not change your answer, okay? Whoops. All right, next up is the associative property. Again, this works for addition and multiplication. All right. This is very similar to the commutative property, and it's very, very easy to get these two properties confused, okay? So you really need to study the difference between the two properties and when one is being used versus the other. But basically, this one says the grouping of add-ins, whoops, and factors does not change the sum or product. So when we talk in math about grouping, we're talking about, usually parentheses are used, and we're talking about which numbers we deal with first. So when you're dealing with the associative property, you have to have at least 3 numbers, okay? And you could group the first 2 numbers, or you could group the second 2 numbers, and it's not going to matter, okay? So if I had A plus B plus C, that would equal A plus B plus C. So notice here what changed was the numbers inside the parentheses. On the left, we grouped A and B, and on the right, we grouped B and C. Same thing would work with multiplication. If I have A times B times C, that equals A times B times C. And the deal with grouping is that whatever is in the parentheses, you always deal with it first. So in this example here, in the first side, the left side, I would either add or multiply the A and the B first, then I would add or multiply the C. Whereas on the left, I would add or multiply the B and the C first, and then at the end, I would go back and add or multiply the A. So a quick example, if I had 7 plus 3 plus 9, we want to know, well, does that equal 7 plus 3 plus 9? Notice the parentheses. So with 7 plus 3 over here on the left, I would have to deal with that addition first. So I would have to say, okay, 7 plus 3 is 10, and I'm going to add that to the 9. I get 19. Whereas on the right, I have to deal with the 3 and the 9 first. So I would say, okay, 7 stays for now, and then 3 plus 9 is 12. And then I would add the 7 and the 12, and look, I get the exact same answer. Works the same way with multiplication. So let's say I have 2 times 3 times 5, and then hopefully that equals 2 times 3 times 5. Again, pay close attention to where the parentheses are. On the left, 2 and 3 are in parentheses, so I multiply that first. I get 6 times 5, and we know that 6 times 5 is 30. On the right, I've got 3 times 5, which is 15. So I keep the 2 for now, multiply my 3 and my 5, I get 15. And then 2 times 15 is 30. So it didn't matter how we grouped these numbers, the end result was the same, okay? Now, I do want to make a very clear statement here. I've briefly mentioned it before, but I want to say it again. These properties do not apply to multiplication. Whoops, they do apply to multiplication. Jeez. They do not apply to subtraction or division. All right, very easily you can see this with the commutative property. If I have 7 minus 3, that in no way equals 3 minus 7. 7 minus 3 is 4, but 3 minus 7 is negative 4, and 4 and negative 4 are not the same, okay? Same thing with division. If I had 10 divided by 2, that is not equal to 2 divided by 10. 10 divided by 2 is 5. 2 divided by 10 is 1/5, okay? They're not the same. And similar with the associative property. If I had 7 minus 3 minus 2, all right, versus 7 minus 3 minus 2, I'm not going to get the same answer. All right, here on the left, I would take my 7 minus 3, which is 4. I would then subtract 2, and I would get 2. Whereas on the right, I would get 7 minus, well, in parentheses, I have 3 minus 2, which is 1, and 7 minus 1 is 6. So you can see these properties do not work with subtraction or division. Same thing over here. If I did 10 divided by 2 divided by 5, does that equal 10 divided by 2 divided by 5? Well, 10 divided by 2 is 5. 5 divided by 5 is 1. And then over here, I would get 10 divided by 2 divided by 5, which is just 2/5. And you may not know this yet because we haven't really talked about fractions, but this would end up being 2 times 5 halves. And we would end up getting 1 equals 25. Not the same. So these two properties, the associative property and the commutative property, absolutely do not work with subtraction or division. They only apply to addition and multiplication. So keep that in mind. All right. The third property that you can sometimes see is the distributive property. Just to be clear, you'll see this property much, much more when you get to tier 2, especially when you're in units, let's see, units 9 and 11, you'll see this much more. But the distributive property is introduced in this unit in tier 1. Whoops. And basically, this property allows us to eliminate parentheses. So it allows us to eliminate parentheses by multiplying through them. So very generically speaking, the property will generally say if you have A times B plus C in parentheses, this is the same as A times B plus A times C. So a quick example with numbers, if I had 7 times 4 plus 9, that would equal 7 times 4 plus 7 times 9. And that would be 28 plus 63, or let's see, 80, 91. All right. So that's the distributive property. Again, you're going to see this and apply it much, much more when you get into unit, or not unit 2, when you get into tier 2. When you're in units 9 and 11, you're dealing with algebra, and you see this a lot more. So just to kind of preface that, if I had something like 5 times x plus 3, I could eliminate these parentheses around the x plus 3. I would multiply 5 and x to get 5x, and then I would multiply 5 and 3 to get 15. So you're going to see this version of the distributive property quite a bit more. Okay, so just to recap really quickly, we had the commutative property of addition and multiplication. The order of your add-ins and factors does not change your sum or product. So basically the order you add or multiply doesn't really matter. Okay, so if I have 7 plus 3, that has to equal 3 plus 7. The associative property is a little different. The associative property is all about how you group numbers. And like I said earlier, we group numbers using parentheses, and whatever is grouped in the parentheses has to be taken care of first. So I have 7 plus 3 plus 9, where the 7 and the 3 are in parentheses. That means I have to figure out 7 plus 3 first, and then apply the plus 9. So 7 plus 3 is 10, plus 9 is 19. And that would be exactly the same if I instead grouped the 3 and the 9. So if I group the 3 and the 9, I get 12. Add that to 7, I get the same sum of 19. I skipped a page there, oops. So then I've got the properties. These two properties, the commutative and the associative property, they simply don't apply to subtraction and division. You've got examples here that prove that changing the order or changing the grouping when you're dealing with subtraction and division simply does not work. And then finally, the distributive property, it allows us to eliminate parentheses by multiplying through them. You've got an example with just numbers, and then you do have an example with a little bit of algebra. And keep in mind, when you're doing the distributive property, it's going to come up much more often when you are dealing with algebra. Okay, so hopefully that's a decent little overview of those two properties. There is one thing I guess I can show you where you have 3 numbers basically, and you can either use the commutative or the associative property. So I guess it is worth showing you that really quick. So just to make sure I cover all my bases, what if I had 2 plus 3 plus 9 equals 3 plus 2 plus 9 versus 2 plus 3 plus 9 and 2 plus 3 plus 9 versus 2 plus 3 plus 9 equals 2 plus 9 plus 3. Now, I can't say directly off the top of my head if Ed Ready gives you examples like this. When we were teaching out of a different book and using a different online product for these types of classes, I would give you examples like this in class. Okay, so what I would ask you to do is, looking at these 3 examples, which one utilizes the commutative property, which one utilizes the associative property, and do any of them utilize neither or both? Okay, so if we look at the first example, I've got 2 plus 3 in parentheses plus 9 on the left. And then on the right, I have 3 plus 2 in parentheses plus 9. So if you look at the parentheses, the same numbers are in parentheses, but they're in a different order. So we didn't change the grouping. The grouping around the numbers stayed, but the order of the numbers was different. So this example right here utilizes the commutative property. All right, so next example, I have 2 plus 3 in parentheses plus 9, and then I have that equal to 2, and then plus 3 plus 9 in parentheses. So if you look at the 3 numbers from the left-hand side to the right-hand side, you have 2, then 3, then 9. The numbers at no point changed order. However, on the left, the 2 and the 3 were grouped together, whereas on the right, the 3 and the 9 were grouped together. So this is the associative property. And then this third example, if you look at the numbers just by order from left to right, I have 2, then 3, then 9 on the left. But on the right, I have 2, then 9, then 3. So we can tell that from the left-hand side of this to the right-hand side, using the equals as the divider, this is definitely utilizing the commutative property. But let's go ahead and check the grouping. Well, on the left-hand side, the 2 and the 3 were grouped together, but on the right-hand side, the 9 and the 3 were grouped together. So this also utilizes the associative property. Now, again, I can't remember right off the top of my head if Ed Ready has examples like this. But again, when we had previous classes called DMAs and we used a different textbook and a different online program, they did have problems like this, and this was something I covered in class. So just to cover all bases with the associative and the commutative property, there you have it. Okay, hopefully this helps. If not, let me know. I'm not sure. I'll have to go back through Ed Ready to see if there are other properties. There are other properties that come up. You can have a property where you have the multiplicative identity, the additive identity. You can have the multiplicative inverse. You can have the additive inverse. You can have multiplication property of 0. You can have multiplication and not multiplication. You can have division properties of 0, division properties of 1. I've specifically been asked about associative and commutative a couple of times. That's why I did these here. If you need the other properties, if you need me to go over those, just let me know. Okay. Again, I can't help you if I don't know what you need. All right. Hopefully this helps. If not, let me know. Take care.